right, ladies and gentlemen, so today we're going to be looking at an application of where we use some of these radicals. And for those of you that have friends in the regular class, they've been working on this. The big difference is they don't have, we don't keep the radicals, or we don't have to simplify the radicals down. So hopefully you can handle this. So today we're talking about the Pythagorean theorem, and this deals with only right triangles. And in our right triangles, we have two different parts. We have the hypotenuse, which is the longest side, and it's always across from the right angle. And in our picture, it's given the letter C. So C is always the hypotenuse. The legs form the right triangle, or the right angle, sorry. And they are given the letters A and B. So these are the legs. So the Pythagorean theorem says that if I take the sides of a right triangle and I square all three of them and I add the legs together, it has to equal the hypotenuse. Okay? And the converse of that, converse is just another way of saying the opposite. We're going to also deal with something called Pythagorean triples, and Pythagorean triples are three integers that satisfy, how about I can learn how to spell, the Pythagorean theorem, but I'm going to write it out since I don't have enough room. So it's three integers that work in there. An example of a Pythagorean triple is 3, 4, 5. Because if I square 3, it's 9. I square 4, it's 16. Square 5, it's 25. And 9 plus 16 is 25. So that's an example of one. So you have to be careful about the directions. Sometimes it might say leave it in simplest radical form. Sometimes it might say round to the nearest tenth, hundredth, thousandth, whatever. Sometimes it might say just an exact answer, which means that you've also leave it in simplest radical form. So in my picture, we have, we're looking for the hypotenuse, so I'm going to start with my Pythagorean theorem. A and B can be reversed, so I'm going to fill in. So I know 30 squared is 900, 40 squared is 1600. My radical, my variable is already by itself, so I'm going to add these together, 2500. And when I take the square root, I'm going to get 50 is C. All right, this is an example of the triple, because then when you have a triple, you can take that triple and multiply it by any scale factor and make it bigger or smaller. So this was taking the 3, 4, 5 triangle and multiplying all the sides by 10. Okay. Over here we have, this time we're looking for A. So this is your hypotenuse. You have to be able to pick it out. It has to be across from the right angle, because C is the one that matters in this formula. So this is your C. This can be A. Oh, sorry, not A. A was already labeled, and that's B. So we have A squared plus 100 squared equals 110 squared. 100 squared is 10,000. 110 squared is 1,000. There we go. Okay. Subtract 10,000 from both sides. So A squared is 2,100. Take the square root. And it wants it rounded to the nearest hundredth, so this turns out to be 45.83, rounded to the nearest hundredth. Okay, I want to get down and look at some with the radicals in them. So I want to actually do number 5. So here we're looking for C. We have A and B. So again, I'm going to start with my formula. A is 4, I'm looking for B. So one thing that you have to remember is that squaring and square rooting each take, excuse me, can go through and cancel each other out. So we're really left with 15. So we have, oh, I filled that in the wrong spot. Okay, hold on, I'm going to redo this. It helps if I'm paying attention to what I'm doing. Hopefully you guys were all screaming at your computer screen that I was doing it wrong. There we go. All right, so now we're going to have 16 plus 15 equals c squared. 15 plus 16 is 31. So I need the square root of 31 rounded to the nearest hundredth, which is, I'm going to put it over here, 5.57 equals c. Okay. Again, I know that I didn't do them all, but I think you're okay. Determine whether each set of measures can be the sides of a right triangle, then determine whether they form a Pythagorean triple. Well, I can tell you right now that the ones that have our square roots in them cannot be a Pythagorean triple. But I still have to see if they meet the criteria just like I did up there. So we're saying if I have to square them all, so 2 squared is 4, 2 squared is 4, square root of 8 is, square root of 8 squared is 8. 8 equals 8, so this one is a right triangle. And I, certainly am not showing all the work that I would need to show, but hopefully you get the idea. So again, here I'm going to do 14 is squared is 4 squared is 16, 4 squared is 16, square root of 20 squared is 20, and 32 does not equal 20, so that is not a right triangle. Over here, so square root of 25 is 625. Square root of 30, I'm sorry, not square root, 30 squared is 900. And 35 squared is 1225. 900 plus 625, and these are not equal. So it is not a right triangle. Let's try this one. So let's see, 24 squared is 576. 36 squared is 1,296. And 48 squared is 2,304. And we get 1872 does not equal 2,304, so that is not a right triangle. We are not having a lot of luck here. Okay, let's try the next one. 18 squared is 324. 80 squared is 6,400. Let's see, 82 squared is 6,724. Oh, look, we got one. So let's see. Add these together, and we do get 6,724. Which means that yes, it's a right triangle, and yes, it's a triple. And I could even reduce those down. I could take them all down to by 2, and that would even make it a little bit slower. So this triple would actually be 9, 40, and 41 would be your triple, because then you can multiply it through. Okay, now we got some big numbers. So let's see, 150 squared is 22500. 200 squared and 25, squared, 62500. Add those together, and conveniently, I believe we do get our Pythagorean theorem. It works. And yes, it's a triple. Again, a triple has to be has to be whole numbers or integers. Whew, that's it. All right, any questions? As always, bring them to class. Have a good night, guys.